Hello everyone, I'm Ashas and my teammate Shriyari. We are going to present you our project which we had created for Hackathon Hack for Bioheritage. As you can see on the screen, the name of our project is Wild Eye in track aiml. The basic goal of Wild Eye is to capture and identify wild animals when it passes in front of the camera. This involves training a model, labeling, and some more stuff you'll see in the video. As you can see on the screen, there are 6 classes. These were the classes which were provided in the dataset during our hackathon. We use these images. We use the images provided in the dataset and then plot bounding box to it. I'm using a YOLO V8 model. So like for YOLO models, we need the bounding boxes to be present. After plotting this, we'll get a label files, which are like this. The first one is for labels. Label index is 0, 1, 2, 3, or classes like 0 is for cheetah, 1 is for fox, etc. And these are the coordinates x0, y0, x1, y0 for plotting the boxes. Let's go to our code. In this code, I have run the model before itself, as it takes a lot of time for computation. Yeah, due to time constraints, I've run it for lesser epochs. After running the model, I've kept all the test images in a file. These are the images for test images. I'll run the model and we can see the output. These are the outputs. Example, you can see here cheetah, x0, x1, y0, y1 with a confidence level of 86%. I know cheetah, lion, and some more stuff like that.
Good afternoon. Myself Hari from Team Data Dolphins. So this is our problem statement: wildlife classifier challenge, and we have used the dataset given here itself. So first off, I'll show you the proposed solution. So we'll be first extracting, we'll be cropping the images, cropping the wildlife animals images, and then converting them into embeddings, and then store the embeddings inside a vector database, and then build a classification model based on which the prediction is detected. So this has more benefits compared to the fine-tuning of pre-trained models. Like I've mentioned in the PPT, it's more efficient. It can store, get back to me. It can store and retrieve information much faster, and scalability. In case of pre-trained model, there might be more of work involved when we want to add additional classes. Let's say right now we have trained for only 6 classes. Let's say in future implementations, I want to have 6 more classes. At that time, using a pre-trained model would be more inefficient, because we need to train again and again. But in vector database case, I can just give the images and all the pipelining has been done. Just giving the images will be sufficient. So it will be cropping the images for the of the animal, and then converting it to embeddings, and then performing all the models. And accuracy also will be way better. Unlike pre-trained model, this won't have the issue of overfitting if there is a more data set. But better the data and more the data, more accurate will be the results. So solutions, all this I'll just walk you through the code itself. So first off, I need to crop the images. This is the given dataset of the foxes and animals. Like you can see, it's not just the fox. If I give the entire image itself as embeddings, it will even consider the background itself. Even the background will be considered for embeddings, and it will be less accurate. So what we can do is we can just crop the images. I have just cropped the images of the animals so that only the animal is displayed, not the background. I have tried to reduce as much as background as possible for better accuracy. So I have also considered I have divided it into test and train datasets. I have divided it into test and train dataset, and I have considered some samples where there are some not normal images. If I have to say, like this image is not complete image, as the background is kind of there is no much of image, and here the lion itself is not, it doesn't have the features of a lion. It has the features of a lion, but the color gradients, it's like a shadow, if I have to say. And here I have a weird looking hyena,